Okay, we have some half-angle trig formulas up next, and it looks like they're all kind of like delineated out on the left here, and we got some special sets of rules over here that we're going to touch on probably in the next video when we start using these to evaluate. For right now, let's take a look at some of the proofs behind these guys. So what we're looking at is the way that these are commonly proved out. And it sounds like a kind of a bizarre first step, but we start off by using the cosecant, I'm sorry, not the cosecant, the cosine double angle, okay, where we know that this is going to be cosine theta minus sine theta, okay? And that seems a little bit bizarre to start off with, because it seems like, well, it doesn't really have anything to do with that. So, but if we go ahead and start to build on this thing, you're going to see why starting off with a double angle is going to make sense. So the first thing that we're going to do is that I notice that I want to have the half angle of sine. So what I want to do is that I want to make this cosine right here. I'm going to use the Pythagorean identity, and I'm just going to put it over here in this part. And I know that cosine squared can equal, if I subtract sine squared from each side, it's going to give me 1 minus sine squared. So I'm going to replace that and write it like this. And now we have our new line that is on the right-hand side sine, and on the left-hand side cosine to theta, okay? So what I'm going to do is I'm going to gather up some like terms, and I'm going to go cosine to theta, and I have on this side 1, and I have 2 negative sine squared thetas, so I go negative 2 sine squared theta. And now what I want to do is get sine squared theta all by itself, okay? So I'm going to subtract 1, okay? And I'll show all the steps on that. So I subtract 1 and divide by negative 2. So I got sine squared theta is going to equal, so I got cosine 2 theta. I subtract the 1 and divide by a negative 2. Okay, so we can see, though, if we look up here, that this is switched around. So what we do is that we take the negative, we're going to multiply the top and the bottom by a negative to get that switched around, okay? So we'll go top and the bottom by a negative 1, and now I'm going to run out of room here, so give me a second to clear this. Okay, and I have this guy, all right? And so I'm going to have to infiltrate into the next column here. Hopefully you can fit it better than I can, because I have to write large. And what I'm going to do is that I'm going to take the square root of both sides to get rid of that square. And remember, when we're taking the square root of both sides of something that basically we have to do a plus or minus when we're undoing a square like that on the right hand side. And so we end up with this business of sine theta equals plus or minus the square root of 1 minus cosine 2 theta all over 2. Okay, and now the final part is this, is that we're going to, instead of leaving that as just a theta sign, we're going to put in a theta divided by 2. And the reason being is that whatever we put in here, like say if I put a 5 in here, a 5 would be right here. Okay, whatever value that I'm going to put in for theta, it's going to appear on the right hand side. So what we're going to do is that we're just going to drop in a half with that, and it's going to go the sine of theta divided by 2, okay, plus or minus, and 1 minus, let me clean that up a little bit, 1 minus cosine of 2 times theta divided by 2 all over 2. And you can see that the 2's cancel out. And at the end of the day, we're going to get the final version of sine of half theta, or theta divided by 2, plus or minus 1 minus cosine theta divided by 2. Okay? And so that's how you would how we derive them out, and these are the most common forms that you'll see. What I want you to do is, in that vein, starting with this step right here, see if you can derive that. So pause the video and give it a try. Okay, so there it is, and hopefully that the magic move, if you will, is to go ahead and change this sine, because we're trying to get cosine eventually all by itself, to, using the Pythagorean identity, to this guy right here, and then you follow the same steps and it just kind of falls apart from there. Let's take a look at this tangent proof. Okay, I had to erase some stuff to make some room here, but what we're going to do is that we're going to capitalize on our sine and cosine identities there, the formulas, and we're going to go the sine of, let's see, use the definition of tangent, which is sine over cosine of whatever angle that you're taking, and we're going to land that first, okay? Then we're going to plug in these identities. It seems like it's going to get out of control real quick, but it's really not. It's not too bad. So when we stack them up, this is what it looks like. Okay, and extending the square root sign, because remember, is that no matter what, if we take the square root of some number and divided by the square root of some number, we can write it as 1 square root of the entire fraction. So I'm going to do that. Okay, and then I'm going to simplify this yucky looking radicand. So it's going, basically, it's going to invert the bottom, flip it, and then multiply. The 2's are going to cancel out, and we'll end up with this guy. Okay, and then we're going to do something kind of tricky here, and we're going to multiply the top and the bottom. And what I'm going to do is that I'm shooting for this guy right here, which is going to be this guy. So I'm going to go ahead and shoot for the sine on the bottom and the 1 minus cosine on top. So I'm going to multiply the top and the bottom by the square root of 1 minus cosine theta, like this. All right, and so what is going to happen is something kind of neat. When I multiply these two together straight across, I know that when I have the square root times the square root, you're just going to get the radicand if it is going to be the same under there. So since 1 minus cosine is the same, I'm going to get 1 minus cosine. I can drop the square root sign, and I end up with that on top. That's good. So when I still have on the bottom, if I multiply those two together, I'm going to get this business of 1 minus cosine squared when I do these guys right here, okay? And so I know that 1 minus cosine squared, if I'm looking at the Pythagorean identity, that's going to be sine squared plus cosine squared equals 1. And so it would follow that sine squared equals 1 minus cosine squared. So I can replace that with just sine squared on the bottom. So I got 1 minus cosine theta all over the square root of sine squared theta, which now when I take the square root of that, I am going to just get sine. And so at the end of the day, I end up with 1 minus cosine theta all over sine theta. And it looks like we got it. Okay, this guy right here. And so we are done proving those out, showing why they work. And let's go ahead and take a look at how they work in the next slide here, or in the next video.